Good morning to everyone. Your big opportunity may be right where you are now. Napoleon Hill. Institution Vision. JPR Institute of Technology aspires to provide technical education in futuristic technology with a perspective of innovative, industrial, and social application for the betterment of humanity. Department Vision. For foster contemporary skills in the field of electrical and electronic engineering, innovative skills and global understanding, nation skills, building for the progress of humankind. Hope everyone is safe and healthy. I'm B. Mahalakshmi, third year student IC Department of JPR Institute of Technology. On behalf of JPR Institute of Technology and Department of EC and EEE, we are glad to invite you all for this event, 6 days faculty development program on emerging advancement of wireless communication and application of power electronics in smart grid system. Faculty Development Program intends to provide financial assistance to facilitate upgradation of knowledge and skills and intends to provide opportunity for induction training to teachers employed in engineering and technology. Now I welcome Mr. A. Anthony Charles, the Head of the Department of EEE, JPR Institute of Technology, to deliver the inaugural letters and introduction speech. Please, sir.
Okay, thank you. Uh, Good morning, one and all gathered here on this wonderful morning. It is my pleasure to welcome everyone for this FDP, Emerging Advancement of Wireless Communication Electronics in Smart Grid. I extended my red carpet welcome to our respected Managing Director, Dr. N. Mary Wilson, and cheerful welcome to our Principal Madam, Dr. L.M. Merlin Livingston, and I also welcome Dr. Kamachi, ECHOD, and I extended my hearty welcome to our chief guest, Pushpavalli Madam, Assistant Professor, Department of Electrical and Electronics Engineering, Satyabama University. Once again, I welcome you all for this occasion. Thank you.
Thank you, sir. Guest profile. Dr. M. Pushpavalli, working as an assistant professor in Satyavama Institute of Science and Technology. She is having 16 years of experience in a reputed institution. She is having a very good exposure on assembling the electrical and electronic laboratory. She completed her BE Triple E in Manonmaniam Sundara University with first class with distinction. She secured Satyavama University gold medal in ME Power Electronics with first class with exemplary. She completed her doctorate Satyavama Institute of Science and Technology. She is certified for 11 NPTEL courses among 9 online certification courses and mentor for 2 courses. She published 43 papers in various international and national journals. Her 2 patents has been published in online. She handled 25 UG projects and 2 PG projects. She attended various workshops and seminars and active organizer in college events. I request Dr. M. Pushpalli ma'am to take over this section. Please, ma'am.
Thank you, ma'am. I think it is visible, ma'am.
Yes, ma'am.
Thank you. So, good morning, one and all. I am just privileged to get this opportunity to present in the FDP. So, I have to thank all the faculty coordinators and conveners, especially Mr. Anthony Charles sir, have been spoken to get this topic. So, thank you all. Now, I'm going to start my topic with research development in power electronics. We all know this is a combination of EC faculty as well as EEE faculties, but this particular talk we are going to see how the power electronics emerging trends in when you see about all the development in the side, the development in power electronics leads to the development in so many areas, not only in the electrical and electronics, it have developed and it have a widespread in all the areas. So now I just have a small glimpse how the development have been forecasted. while you are looking on to that, we have started with the traditional incandescent lamps, and now we move on to that light emitting diodes. While we are moving from this kind of this, the watts power get keep on reduced from 100 watts to halogen incandescent lamp 77 watts. Then we move on with the CFL, that is 23 watts, and nowadays even below 20 watts also we are having that light emitting diode. But while seeing with that, the time period, the lifespan of the electrical, while I'm seeing from 750 hours, 1000 hours, 10,000 hours to 20,000 hours, nowadays all the LED are working. But obviously the price of the uh, light will be high only. But even to that, we have reduced the watts, we have increased the lifespan, and we have got the sufficient kind of thing with the same amount of price. When you see to that, the price of the bulb which is mentioned in a dollar, but when you see to that, here the price is around this, but the life period as well as the watts are very very important. That we have achieved today, not only in the light. You have seen the development in fans. Okay, now when you see with that, while the day heavy duty metal fans will be there, but nowadays all the motor which is operated with the plastic models, and before going completely bladeless. So there is not only the development in the lamp, the development in the fans. Okay, then TV, the another growth, the tremendous growth we can see to that. While we start with the TVs in that 1920s to until 2021, our TV size will be become slimmer and the size of the screen become larger. So all that due to the development. And the car, the next one. So while we see to that, nowadays we are not stick on to the mechanical related, everything is embedded related. Even we were not locking the key with the help of key, everything is automatic, we are using the switches to open or any kind of thing. The tremendous development from 1900 to 2010, everything is automated, and serial communication inside the can using controller area network for inside the car, and we were controlling our dashboard controls, everything will be taken over by that. So while we see to that, this development from light, fan, TV, car, it's not to that, not only to that, the requirement as well as the developing the power, it's also one of the very important target for us. So when you see to that, from coals we have developed, then coal powered steam engine is there, then we have seen that solar power, but maximum of the power we are stick on the coal. Nearly when you see to our India, 53 to percentage of the power we are stick on the coal. But now we are all moving on to the renewable energy side. So the renewable energy side not only sticking on the single renewable energy, we are doing the hybrid renewable energy. So more of the research development we are stick on to the energy demand, that for that energy growth is also needed. So here, while I'm going from my evolution of the electrical power from 1862 till the date, the electrical power, there is a tremendous development of electrical power. There we have a centralized power, then we have transmitted using the long distance transmission, then site based we have a distributed power, and even a single building can able to embed the power and it can develop, and we have depend on the batteries and electric vehicle. So this is the evolution of the distributed electrical power from power station to electric vehicle. How? Because now the 80 percentage, we are saying the 80 percentage all electricals used by DC based power electronics. But when you go with that, because we are all dependent on battery, so batteries also plays a one of the major role on in developing the power. Okay. Now we will see why the power electronic, why the research development in power electronic. While we see to that, we have the United States National Academy of Engineering. They have give the importance of engineering on the 20th century, so that while seeing on the list, the internet take the 13th place and highways take the 11th place, but the top of the list, the electrification is our electrification as made by electrical power grid. So that much of importance is in our today's achievement of the 20th century. The electrical energy is very very important. Not only the electrical energy, it have leads to so many advantage like advanced computer communication control technology throughout the 20th century. The significant electrical achievement there. Okay, and this is some of the world map while we see that energy demand as well as energy growth. While we see to that energy demand and energy growth. So here, while I am seeing to that, when you see with all our countries, actually electricity demand is always twice. Even when you look up India, our 126 percentage is our primary energy demand, but the growth of electricity demand is 282 percentage. So almost in all the countries, while we see with the growth as well as demand, it will be always the twice the time. So the energy requirement and the energy demand is one of the most important thing in the worldwide energy challenge. So even the smart grid, while we move on to that smart grid also takes the place. While we are seeing in the list of development, the electrification plays a first role now. In that smart grid is playing the first role. So what it needs now, it needs integration of renewables, reliability and efficiency, demand response, integration of electric vehicles. So all that includes that smart grid requirement. So integration of the renewable is one of the most important requirement, because while I'm supplying to my demand, the integration of renewable energy is one of the foremost thing. So now it one not only include the generation, it includes the generation, transmission, distribution, and all automation, IT and power devices. Everything will be done in the integration of renewables. Okay, now technology. While we moving on to that, there is development like virtualization, business intelligence, cloud computing, web oriented architecture, communication, server. All this are, when you see to that, the green it for green. While we are going for energy demand or energy growth, where we have to always concern with our uh, public. So zero emission of without any carbon dioxide emission we have to develop. So that are very very important one. So they are all focusing on green it for green. Okay, actually, this is one of the important diagram which shows that even we are getting the power, how our power is exported, power balancing, power consumption. So we cannot able to stagnate that. We all know that. So power import. So this is our integrated energy system. We doesn't depend on a single energy source to meet out all our requirement. So it is a collective. Similarly, while we are meeting out that, we are supposed to export our power and we are consume our power, and power balancing, everything has to be in the electricity system. So one important word in the energy development or research development in integrating the energy, that is very very important needed. That integrated energy system only leads to the development in the smart grid, leads to the development in the society. And it doesn't depend on the like coal and all. So far that integrating the energy system is one of the foremost and important one. So while we are taking the integrated energy system, so we were always look upon wind turbine, small biogas plants, solar, all this will put together. And we all know that it is a building block. We can put everything and we can have the sustainable energy to develop in one side, and we can able to transmit. So that maximum utilization of energy, renewable energy sources and supplies are very very important for integrating this energy. So while we are seeing why we are sticking on the renewable now, we all know that the foremost point is carbon dioxide free future for energy production. That is the foremost point while we are discussing. uh, that always leads to that, if we depend on carbon dioxide, if we want to produce the energy with the help of renewable energy, we can have a carbon dioxide free future of energy production. That's why. And another most important is the primary source. While I'm using my renewable energy, it meet out all the future demand like electricity, heating, mobility, all this kind of will be that, and entire global are depending on this integrated of renewable energy. But we all know that in our area potential, solar availability throughout 365 days, it's available in our India. Okay, so uh, the topic is research development in power electronics, where I have to do my research. While seeing to that, my technology development, and in the list the electrification is at the topmost, but the research is still going on. So where I have to start the energy, so where I have to start my research in that. While we look up on this particular diagram, I may start from supply side to till my grid side. All parts are the research area. Whatever I have mentioned here, all. So even you have done a small improvement, that will give a big lead development in the renewable energy side. So this is the particular diagram. It's a well-known diagram. It is a grid connected hybrid renewable energy system. So when you go with that, here PV, wind, battery, so various energy sources are there, we can integrate. So there we can go with the different types of solars, different type of wind turbines, and different type of batteries there we can take up. Not only in the input side or supply side, the converters, DC to DC converters, we all know that buck, boost, sepic, all converters are available. Particularly this DC to DC converters play a vital role on converting the energy. So we all needed the boost converter to boost up our DC level. So for that we can do our research area in the DC to DC converter, or we can do the research area in the MPPT. we can we can do it in this DC to DC converters. And near DC to DC converter, and we have a MPPT algorithm, maximum power point tracking, so that we can able to get the maximum power at the end. So even we can go employ with so many MPPT techniques, and we can say this is the suitable MPPT technique for to do my research. So MPPT algorithm we can go. And we all know that here I have employed the DC bus. You all know sometime we can go with AC bus and all. So there which having a more advantage on that. So this will be a DC bus, in that we will use the capacitance and all. So there we can do our research. Then inverter side. So definitely while I'm giving my uh, supply to my grid, I have to go always with this inverter. So there inverter side I can do my research. And not only the inverter, the controller also play a vital role. So controller also we can focus and can do our researches. And even in the filters, you may think, oh, this is a filter, various filters will be there. We all know that the filters also play to get a sinusoidal waveform. So and grids, while we look upon this grids, the grid also we can able to integrate the power. So grid connected hybrid renewable energy system means the research may be start from the supply to load side till the grid. There is so many optimization techniques are there. And in we can do our research in converter side, we can do our researches in MPPT algorithms, we can do our research in the capacitors, we can do the research in the various types of inverters and loads we can use, controllers we can do the research, filters we can use. While I'm want to connect with my AC grid, there are so many optimization techniques are available, and so many integration process are there. So each and every part is the research. So research development in power electronics, developing while we are move on to this particular topic, we were saying that the development in the lamp side, fan, and entire technology, there is a boom is there. But you all know when I'm developing all this thing, the primary source is energy. So the energy development, without energy development I cannot able to go with any other thing. So energy development is the one of the most important one, and in that we are saying that we can do our the research and we can expand the development, and we can give the researching idea to the other young researchers to give a leads to that. I can say to that this particular diagram, you can start your research from your source sites to grid site. You can think over any of the part, you can do it. The entire part you cannot able to do any development. You can choose any one of the part, and in that particular part, you may do the development. Okay, so now I'm just going to give a small research development I have done in the converter side, that is my KY post converter side. That I will tell you what is that research development. And one more thing in this particular FTP, I'm going to explain one more software for also, because you all know that all this when you take with that the simulation play a vital role on developing this research. While simulation, whether we are getting the accurate results, it's not 100%. We cannot say it's a ideal condition. It may be some 80 to 90%. There is a difference in that. But now so many renewable energy tools are available in a market where I cannot able to connect all the hardware models because the cost will be very high. We can do the development in the simulation. At least we can give the justification that this particular thing is doing some improvement. For example, I'm using one converter. I can say this converter give a suitable in the integrating my renewable energy. No, not only the converter. I can say that this MPPT term technology is helping to get this improved version. Not only that, I can go with that. I can go with some AI controller is helping, or else PID controller itself doing. So that kind of research we can do with the help of connecting the hybrid run. So research development while we are doing in the power electronics, we are focusing on energy development side. So energy supply is always needed. In that energy supply, we are supposed to meet out the requirement. We all know that the global, we have a growth as well as the demand, all are twice while comparing with all our country. Even India, we have a 128 percentage of primary growth now. The demand is 256 percentage. It almost doubled. So the energy supply requirement is one of the thing. But the energy supply is needed now. The environment we have to protect. So for that we are going with this kind of renewable energy development. And not only for that, once you wait for some years, the smart grid will comes into the picture. So while smart grid comes into the picture, the renewable energy sources are very very important to integrate all the energy supplies. Okay, so now this is the flow I'm going to tell you. First I will tell the research flow objective, and what are the literature survey, and what are the analysis I have done. That is the content I'm going to tell. Okay, so again the same reasons why we are moving for renewable energy. Okay, so all this fossil fuels, oil, are the current scenario, it will leads to depletion from the earth. So to increase the energy, global energy demand, and for we are focusing on hybriding the energy. And you all know, not only India, the entire world is allocating more fund for get the renewable energy. So when you see with the Australian, they allocated nearly 1 billion funds, and China, they have allocated the revenue around 11 percentage for the solar wind market. And South Africa, they have put up around 12 million for the hybriding of solar and wind energy. And when you see that our own India, we have so many government encouraging policies are expected to boost up the hybrid solar wind energy. And not only that, our US is also focusing on the growth of hybriding the solar wind and energy. So all the country, they have allocated some fund, and they are giving more importance to get the renewable energy. Okay, so now these are all the objective, because I told you I have chosen one KY boost converter, one KY boost converter for my research, so that this is my objective. So what are the objective I kept now? I want to hybrid the renewable energy. The next I have kept, I have to do it in both open and closed loop. And the next I have fixed, there should be improvement of power factor, as well as a reduced total harmonic distortion. And then I have to do the energy management with the help of this hybrid solar wind system. Okay, so this is the objective. But while I'm going the research gap, yeah, those who are doing research, they have to identify which part have been left out. That is the research gap. Here, researchers has to identify. The researchers once identified, they have to focus on that research gap, and they have to take the area. I told you the particular slide, everything they have explained with this. So while I am seeing that the KY boost converter, the multi-input KY boost converter, they didn't implement it for the renewable energy applications. So that is one of the advantage. And they using this hybrid framework, you all know all this renewable energy is not a linear load; it's a non-linear. So obviously, due to varying weather condition, also my structure has to work properly. So all this I have research gap I identified, and I have chosen my multi-input KY boost converter for the development in the renewable energy side. Okay, so this is the block diagram. So I am using solar, wind, and battery. So you all know that for wind turbine I use the rectifier. So that is given. Why I am saying multi-input now? One input I will receive from solar, and another input I will receive from wind. So the two inputs are there. So it's a multi-input KY boost converter, and that will be fed to the one DC bus. And this DC bus have a constant DC bus. And you all know that battery backup. Your the power wind is available only in the nights, and solar is available only in the mornings and all. So, but my energy has to be stored. So there is a battery will be there, and the inverter setup, and I have given to load. So what are all I have missed in this now? I didn't go with any grid connector. Is clear? I didn't focus on the grid connector. And one more thing, I have used the fuzzy based MPPT controller. But in the fuzzy based MPPT controller, I have seen the literature review. I have chosen fuzzy as well as uh, perturb and observe algorithm. That is my MPPT method. So that my area is only in this converter only. I didn't touch any other area. All other area I have just used. And you know that here I didn't connected with my grid. I didn't connected with my grid because I just connected because it is the next development. Why I have employed this successfully. Then next I have to integrate with my grid connection. Okay, so you just see to that it's a solar, wind, and then I have to rectify, and I am focusing only on this KY boost converter, that is multi-input KY boost converter. Is clear? Okay, and this is my flow of research. So I have done the literature review on my converters, KY converters, multi-input converters, MPPT, okay, and controllers. So I have chosen one is my KY converter, two is my multi-input converters, three is my MPPT, and four is my controller. So all this I have done the literature review. So the literature review, while you are reviewing all the literature review papers, you may come to the conclusion that this is the most advantageous method, and this have some disadvantage. This is the research gap. So from that we can identify. So if you are doing any research, don't project your idea first go with the literature review, and from the literature review you can identify the topic. So doing any kind of research, always the review, literature review will give a betterment of your research focus. Okay, And then I have done this. You all know traditional converters, all this boost, buck boost, sepig, zeta, huck, all these are the traditional DC to DC converters. Among that I'm saying my KY boost converter has a better. So I'm taking all these six converters, I am comparing all the converters, and I'm justifying this KY boost converter is advantage than the all these converters. I'm doing this comparison not only simply that I'm doing open loop as well as closed loop, so that while I'm analyzing in open loop and closed loop, I'm coming to the conclusion this converter is a better converter. I will show my results also. And then I moved on to doing the research in the controller also. Okay, which controller is suitable for my KY boost converter? So I have chosen normal traditional PI controller with fuzzy logic controller. While comparing that, again my fuzzy logic controller give a better results than the PI controller. So I have chosen the fuzzy logic controller, and connecting everything, the energy management I have achieved. Okay, so I told you the most important as a faculty, we are supposed to know the most important literature survey. So that literature survey, I have chosen this four thing. One is KY converter because I am going to do the research in KY converter, and I am going to identify which controllers are a suitable controller and what MPPT algorithm I have to adapt. And I have to do KY converter is available, multi-input converter is available. So I have to combine this KY with multi-input, so that I have to analyze my literature survey in multi-input converters also. Okay, so literature review on KY converter. While you are going with that, this is the thing I have done. So many KY converters, even it starts from 2007 to 2017. I have taken what are the methodology, what is the supplement components, what is the accomplished objectives, and what are the qualitative comparison. All these researches I have taken the paper which is from 2007 to 2017. Even I am doing my research, I've taken any paper which I have published related to this converter. That particular paper have been taken and the analysis have been taken. So among that, while I'm doing all the analysis of doing the literature survey, I have identified this particular single stage KY boost converter is suitable for my research. Why? Why? Because now this having the advantage of low ripple, high power applications, and stable converter. Stable, low ripples. We all know it leads to less DHT. High power applications. Definitely, I am using my renewable energy and a stable converter. Stable converter. How I can't say in terms of simply it is a stable converter. That's why I have given some small disturbance. Why? Because giving small disturbance now, all these renewable energies are non-linear flow. So even doing the non-linear, how my converter is working stably or not. So by comparing all the converter, I come to the conclusion this particular converter having the advantage of this can be taken for the multi-input analysis. So this KY boost converter I have taken. So inference, this is my inference made from the literature survey. Okay, then I have done the literature review on controllers. So many controllers I have taken. So first I have done the literature in the KY converter, and I come to the conclusion that particularly this particular KY boost converter is suitable for my research. The reasons: low ripples, high power, stable converter. These are the reasons I have given the justification. Okay, and then controller. While going with that, I have chosen my input is renewable energy only. So that renewable energy is needed now. For that particular renewable energy, which controller is suitable? You all know the researcher, not we are saying the renewable energy development from 2000 to 1994 itself. They have started doing the research in PV. You have seen I have taken various sources: PV wind, PV wind PV diesel engine, PV wind PV battery, wind solar, electrolyzer, fuel cells, all equipments I have taken, and I have seen what is the controller. So while we are going with that, there are so many controllers they have adopted. While seeing there is a fuzzy logic controller is there, neural network controller is there. Okay, and while moving with that, dual mppt with flc will be there, or fuzzy pid controller will be there, wavelet transform neural network will be there, fopid, fopa. So while I'm doing the research on the source as well as using the controller side, this is the combination I have done with the various renewable energy sources and various controllers all there and various methodologies there. But starting the research from 1994 to till 2021, they were saying that the fuzzy logic controller is very suitable for mainly for the renewable energy. I'm not telling this particular control is suitable than all other control. That is not the conclusion I can make. I can say that for my research area, especially for renewable energy side, especially this controller play a vital role. So that's why I have chosen this fuzzy logic controller in my area. Okay, so while it move on to that, what is the inference, why I have chosen the fuzzy logic controller? The reason is fast and good performance. While we see to that from 1994 to 2021, there is so many controllers, neural controllers, pid controllers, fuzzy logic controller, adaptive controllers, so many controllers are available. But among that, fuzzy logic is the best intelligent controller for hybridization. That is the thing. Fuzzy have a tremendous and very important controller. Why? Because na fast and good performance. Okay, less fluctuation, maintaining the constant DC bus, stable operation. So once again, while I am telling about that fast and good performance, that is the thing, less fluctuation. And this is the reasons, this all the reasons made to me to choose the fuzzy logic controller is the best controller for hybriding my renewable energy sources. Okay, then literature review on MPPT algorithms. While we are doing with that, MPPT algorithms also, why? Because now I'm not choosing fuzzy logic controller alone. You all see, while I'm going with my block diagram, I've told you that fuzzy based MPPT controller. So MPPT controller is also needed for me. So I have done the research area not only in the controller side, I have to do it on the MPPT side also. So while doing the MPPT, so many MPPT techniques are available. Since the research we made from 2006 to 2021, there are so many MPPT methods are available. So while you see, there is a direct seeking methods, indirect seeking methods are there. So they are saying that direct seeking method have more advantage than the indirect seeking method. So this is they have compared so many MPPT methods. So I have also tried to use that direct seeking method, and in that uh, perturb and observe method, Fibonacci based MPPT method, FLC based MPPT method, de-optimization techniques, hill climbing MPPT method, single sensor MPPT controller, unified MPPT controller, artificial intelligence based MPPT controller, all the MPPT techniques are available. So while we are see to that, to get the maximum power, that is the main agenda for the MPPT algorithm. We are supposed to get the maximum power. So the maximum power, if I want to attain, the main thing is the direct seeking method is the most suitable, and among that, perturb and observe algorithm having the most important one, and it having the so many advantage like good stability and high efficiency. So for this following reasons, I have chosen the perturb and observe algorithm. So perturb and observe algorithm is the frequently used algorithm for PV and wind energy transformation system. So combining the so many intelligent controller with MPPT algorithm, we can track the maximum power along with the generation of the duty cycle for converters. So MPPT algorithm, so many MPPT algorithm like de-optimization, hill climbing, MPPT tip, all the methods are available. Among this is the PNO, perturb and observe algorithm is the suitable. Okay, then literature review on converters. while we going with the converter, we all know that I have compared so many converters are there, and among boost converter is always needed for that, and they have justified the point. Boost converter is only needed for boosting the energy to hybrid the renewable energy. Boosting the energy is a essential one, and always going with the boost converter, high efficiency, low THT, and we can have the controlled MPPT circuit verified with current control MPPT techniques also that. Okay, so then literature review on multi-input converters. So multi-input, what is multi-input now? While we are seeing that two inputs will be there. So here, while we are doing with the multi-input converters, there are so many types of multi-input are there. Magnetically connected multi-input converters, electromagnetically connected multi-input converters are there, electrically connected multi-input converters are there. So again, the research is started from 2002 to 2021. So many multi-input, different types of multi-input converters are there. Magnetically connected, electromagnetically connected, and electrically connected multi-input converters are there. So while we are doing this research, I have chosen electrically connected multi-input converter. Why? Because now they have give the justification that electrically connected multi-input converters is always more suitable for the renewable energy system and electric vehicle systems. So while you see to that, the multi-input topology, I can combine two different level of sources, and I can combine to get the single output, multiple input and single output I can achieve using the multi-input converter. Why? What is the advantage? Going with the different DC converter, the size of the system will gets bigger. So to reduce the size, to that we are always going with the multi-input converter technology. And here, one of the author Liu, in the year of 2009, he have told about the six different converters: buck, boost, buck boost, zeta, sepic, and cuck converter he have taken. And that multi-input converters also I have taken for my research, which is best converter, whether a buck or boost or buck boost or zeta or sepic or huck or that. From that I made a conclusion, and I compared my multi-input kpi boost with all this converter, and I made the conversion, made the conclusion that, among all converter, my multi-input kpi boost converter give a betterment in the results. So this is the advantage of multi-input non-isolated converters. I told you magnetically coupled converter is there, electromagnetically coupled is that. Among that, why I have chosen that electrically connected multi-input converters and all na, because of this reasons: low cost, minimized component, high efficiency, high reliability, less switching and power losses, and the control schemes are effective, suitable for the renewable energies applications, and power security, managing the renewable energy with the improved efficiency. So all these reasons made me to choose the multi-input non-isolated converter. Okay, so this is the see, the taken nearly some 44 slides to explain only to conclude the literature. So when you take your research, your major part should be play in the literature survey. So the literature survey, and from the literature survey you have to make one literature inference. So here when you see this ky boost converters and this controllers, fuzzy logic controller I have chosen, and in mppt I have chosen perturb and observe, and then there I have chosen multi-input non-isolated converter. So this is so four area I have done my literature survey, and from the four area I have chosen, uh, this is the best converter, and this is the best controller, and this is the best mppt algorithm, and this is the suitable multi-input converters, non-isolated converters for my research. Ma'am, am I audible, ma'am?
Yes, sir. Yes, ma'am. You're audible, ma'am.
Yeah, yeah.
You
Okay.
can
So,
continue.
okay, thank you, ma'am. So, drawback of existing method. So, while we see to that, I already mentioned that why I gone for multi-input converters. Now, multi-input converters, I need so many converters to connect. So, the system become too complex, and the numerous conversion stages also there. So for that I have chosen a single dc to dc to converter. To there I can connect my multi input different there I can get my single output. So for that I have gone with this multi input concept, especially with the ky boost converter that is not available in the research. And you all know the buck and boost will affect the stability of the system. Okay, but this particularly this ky boost converter betterment than this converters. Then the interleaved boost converter remove all the ripples and increases the switching losses. While go with my interleaved concept, you all know the interleaved concept where I can remove the ripple, but interleaved I can connect two converters in parallel. That leads to so many component will be connected. That leads to the increasing of the switching losses. So this is the drawback of my existing methods. Okay, and this is the advantage that I have proposed. The advantage, in that proposed advantage I am saying that the novel ky boost converter have a advantage of simple topology and high voltage ratio, high conversion of voltage ratio, and the power conversion. By using multi input concept I have reduced the number of power electronic devices as well as converters. Okay, now I'm going to explain this multi-input converter open loop analysis. Okay, so these are the 6 converters I have taken for my research. This is the multi-input boost converter, and this is multi-input buck boost converter, and this is multi-input SEPIC converter, and this is multi-input Huck converter, and this is multi-input Zeta converter, and multi-input KY boost converter. So all this, while you are looking onto the picture V1 and V2, actually while I am doing my open loop analysis, I didn't connected any of my renewable energy sources. I just use the DC sources only. We all know I have used PV as well as my solar, sorry, PV as well as my wind. So definitely wind I will rectify and I will give the DC voltage. So both I will get it from my renewable energy. Assume V1 is from PV and V2 is from wind. I have used and I have done the open loop. So without any controller, just applying the input voltage, I observed. I observed what I have observed in that now. Just I have observed the output voltage and current waveform and voltage stress across the switches and voltage stress across the diodes. This is the parameter I have analyzed in the open loop I have analyzed these things. So while I have made a comparison chart, and in the comparison chart I made my voltage ripple and current ripple is reduced than all other converters, and my voltage ratio, voltage gain means what, v naught by v in equal to 2 or 2 minus d by 1 minus d. This d is nothing but my duty cycle and voltage stress on the switches and the voltage stress on the diode. This analysis I have done with all the 6 converters, and this makes to me that among all these converters, my ky boost converter having a less voltage ripple, less current ripple, and as well as it having a high voltage conversion ratio, and the voltage stress across the devices are very less. So this I have made in the open loop analysis. Okay, so this is the various comparison chart I told you now. While I compared my voltage ripple and current ripple with all the converter, and this is the voltage ripple and current ripple. I have made it for MIC multi input buck, buck boost, sepic, huck, zeta, and among that my KY boost converter having a less voltage ripple and less current ripple. Then I have done my analysis on voltage gain ratio, where I have taken my duty ratio in x-axis and my voltage gain in y-axis, and I have made it that my multi-input KY boost converter consume less voltage and current ripple, and the voltage stress across the switches are very low comparing to the other converters, and the comparison of voltage gain of multi-input converter, in which it comparing with other converters, this multi-input KY boost converter is superior to other converters. You just see this my line which is tracking. I have done my value from 0.5 to 0.95. You all know you all know the boost is ky boost and it is a boost. So while you see to that my boost is also lesser than the ky boost converter, and my other converters is also will be less than, and I can say my voltage gain of ky boost converter is more than the other converters. Okay, and this is my multi-input converters under the closed loop analysis. So I have taken the closed loop analysis, and in closed loop analysis, why I go for I'm open loop analysis itself, it says to that my converter is a suitable converter. Why I did in closed loop now, the most importantly I'm going to check the stability of my system. To analyze the stability in open loop, how I done my voltage ripple, current ripple, I have done the analysis of voltage stress across the switches, voltage stress across the diodes, voltage gain. I have compared. Now, in closed loop, closed loop, what is the four and most important thing I'm going to take now? That is my uh, stability of the system. So, how I checked my stability now? By checking the poles and zeros values, and then gain margin and phase margin. So, obtaining the Bode plot, I am checking the stability of the each converter, and again there also I have done the analysis. I have done the analysis, and in that particular analysis, how there is a tremendous, how there is a improvement on that. Okay, so you just see to that. Here I have taken the two inputs V1 and V2. I have done in the multi inputs boost. All six converters also I have done. So this is my V1 and this is my V2. We all know that all this renewable energies are non-linear, and then definitely there will be a change in or fluctuation in input will be there. So at that time, how my controller is tracking that and getting the output voltage without less disturbance and less ripple, we are just going to observe. Not only that, we are going to observe the stability of the system. That's very very important. Stability of the system, how it is stable, how it is stable in terms means how it is stable in term of poles and zeros, gain margin and phase margin and all. So you just see, I have applied some around 50 volt I have given in my input, and I have give a small disturbance here. So around zero point 0.5 seconds I have given, in zero point 0.5 second I have given a small disturbance. Then again my voltage will be there. So how this is my input voltage and this is my output voltage. So while you see to that, while there is a change in input voltage, how my output voltage is tracking, and what will be the peak overshoot, and what will be the settling time, and what will be the steady state error, everything will be monitored in this graph. So this is in terms of, we are explaining in terms of time domain parameters of the control system. So all the parameter like peak power, settling time, steady state error, all this will be taken in terms of time domain parameters of control system. But when you go with that, while we are speaking the stability of the system now, Bode plot, I think the Bode plot, these two commands, I have used these two commands to get the transfer function, and from the transfer function I have obtained the Bode plot. So while I am see to that, I have obtained the transfer function of multi. Why I am getting two transfer function? Now very simple logic behind here. Here this is my supply one and this is my supply one and supply two. Now here two input and single output. We all know that the transfer function means output by input. So I have taken the transfer function of both output by input and output. So I have obtained two transfer function, and how my transfer function is, so how my transfer function plotting my Bode curve and gain margin value, phase margin value. While see to that, here while I'm speaking about this gain margin and phase margin, we also know to that all this value with my gain margin value should be positive and phase margin should be positive, and gain margin value should be always greater than 1. This also leads to that my system is a stable one. So once I obtain the transfer function, I already mentioned that using this command I have obtained the transfer function, and from the transfer function I have obtained the Bode graph, and from the Bode graph I have obtained the gain margin and phase margin. So comparing to that, here my this phase margin is negative. That means I can say this particular system is not a stable system. And while to move to you moving to the pole zero plot. So, okay, so using this transfer function I have obtained the pole zero plot, and we all know one important point on that. When my poles and zeros are lie on the left off of the s plane only, it is a stable one. If it lies on the right off of the s plane, it is a unstable system. If it is lies on this marginally stable, we used to say. But once I have seen to that, all this converter are lying on the right of this. So why we are getting two pole zero now? We have a two transfer functions are there. So to that I have obtained the pole zero plots, pole zero values, and that pole zero values I have plotted in the pole zero graph, and there my zeros are lie on the right of the s plane. I am stating this particular multi input boost converter is not a stable one, so that I have to move to the next to one. So the way I have done the analysis in all the buck boost converter, sepi converter, same concept, huck converter and zeta converter, and then ky boost converter. This is my last analysis. So to that all the converter, while I am looking on to that, all my converter is not a stable one. You just see that here one right off of the s plane, and while you see to that here also in the right off of the s plane, and here you see to that here also lie on the right off of the s plane. In zeta converter this also lie on the right off of the s plane. So I have done the multi-input KY boost converter, and in that you just see this is my PA controller. So I have a two inputs, and you all know there will be one output voltage. I fixed my output voltage to my reference voltage is 325 volt, and this is my actual voltage, and the error will be fed, and the error will be given to PA controller, and according to the error, whether my it will generate the pulses, and the pulse will be fed to the four switches, and then we will get the output voltage waveform. So while I am see to that, this is my transfer functions. So while I am see to that, all my gain margin and phase margin values are positive, and all my gain margin value is greater than 1. So I can say that my ky boost converter is a suitable converter, comparing all the parameter like rise time, fall time, overshoot, set value, final value, steady state error. All this have been taken. All these parameter have been taken in terms of control system, and gain margin and phase margin, pole zero locations. This is obtained from the transfer function, and gain margin and phase margin we have calculated using a Bode plot, and stating that comparing with all the converter, my KY boost converter having a less rise time, and while comparing with that it having a less fall time, and then overshoot in percentage, and how it reaches the set value, and what will be the final value, and steady state error, set value minus final value. And while comparing this converter alone, I have set the different set value. Most probably for all the converters I've set the same set value, even though comparing with the other converter, my ky boost converter gives the better results than all other converter. So this is the comparison or of various converters under the closed loop condition we have done. So this first point, steady state error, and the next one comparison of time domain, like rise time, fall time, peak overshoot in percentage. All these parameters have been taken, and then I have chosen multi-input Kiowa boost converter consume less rise time, fall time, and overshoot in percentage. And similarly steady state error is also less very comparing to other converter. So stability of multi input ky boost converter is also good, and the comparison not only done in terms of stability, it is done in terms of comparison of time domain parameters and a steady state error also. We are saying that my converter is superior to other converters. So this is the area. Okay, now I think I have done the analysis on multi input ky boost converter. So this is the converter I have seen. I have already the who have developed this converter in a single stage. I have developed in a dual stage, and in the dual stage, and the values of the capacitance inductance I have taken from that base paper only, and I have done the operation, mode 1 operation and mode 2 operation. Why? Because now here we are telling in terms of body plot my system is stable, but you all know state space equations is one of the very important one. So to analyze that state space equations, we are going to analyze in mode 1 as well as mode 2. So after obtaining this mode 1 and mode 2 equation, you see to that v1 I will get v2. So one in one mode of operation my q1 and q4 is on, and in another mode of operation my q3 and q2 is on. So this is the way I have developed, and by solving this two mode equations I have got my voltage gain v naught by vi equal to 2 minus d by 1 minus d. By obtaining this equation I can say that my converter high voltage gain converter than other converters. Okay, these are the switching pulses connected to, and voltage across the inductance, voltage over the switches, and voltage across the capacitance, resistance. So for example, va I'm giving 100. 100 means v1 plus v2. V1 is 50, v2 is 50. Now 100 by, even I am kept my duty cycle as a point 0.5. Now I'm getting around my voltage, around my output voltage is around 300 volt. So this is my voltage gain versus duty ratio, and this is my efficiency. I have find out the converter efficiency output by output plus losses. Losses I have taken two of my losses, conduction losses and switching losses, and this is the overall system configuration. There how I have analyzed my state space equation. State space equation we always do for four energy storage element here in my circuit. So I will do it for my two capacitor and two inductor. How for na? I'll see to my diagram. This combining I'm combining these two input inductance as a one single input inductance, one buffer capacitance, one output inductance, one output capacitance. So while I'm see to that, I'm having two inductance and two capacitance to analyze my state space equation. So while writing your state space equation, always remember that we will write in terms of current flowing through inductance and the voltage across the capacitor. So that this is my state space state equations, and this is my output equations. So from this also I have obtained the transfer function. So in another way I'm just simply say I obtained the transfer function using the MATLAB command, but still more there is a contradiction in the research that how can you say it from that. So that I have taken my converter separately, and I have done all the mode 1 mode 2 mode 1 equations, mode 2 equations, and from mode 1 and mode 2 I came to the conclusion that I have obtained my state space equation, and from the state space equations I am stating that I have obtained the root locus as well as I am getting my step response. All this made the point I am saying that here also all my poles and zeros lies on the left of the S plane, so that my system is a stable one. So I have done the multi-input KY boost converter in MATLAB to obtain the stable of the converter. Now I have taken the converter separately, and I analyzed in mode 1 and mode 2 operations, and then I have obtained my state space equation, and from my state space equation I got my ABCD value. You all know this is A of x of t, this is B of u of t, then y equal to this is C of x of t plus du of u. So from that I have brought my model in the same way. By getting my A, B, C, D value, I got my transfer function, and again from the transfer function I have got my body plot, root locus, step response, and then pole zero plot, and I made the conclusion again my converter is a stable converter. Okay, then this is This is one of the most important part. The renewable energy fed multi-input KY boost converter with open and closed loop. Open and closed loop. So first I have done in open loop. So far I have not connected any renewable energy because how our research is started. Research is started with renewable. There I have employed the converter, and for that particular converter I have identified which is the suitable converter and which is the suitable controller and which is the suitable MPPT techniques that I have employed, and I complied and I compared with the traditional converter, and from the traditional converter I have got the best converter. Now when I'm moving on to my analysis, here I have directly connected my solar, and here I connected my wind, and this is my PV panel voltage, and this is my DC voltage there. This is my converter, constant DC bus and inverter. I told you already I'm not fit to the grid. I just simply connected to the AC load. So while I am employing again, this is the simulation. While I am seeing to that, my voltage across resistive load, current, active power and reactive power I have obtained. So this is the formula I have used. V naught output voltage, 2 minus d by 1 minus d into Vi. So where I have used get my duty cycle, I found obtain my output voltage, and then phase voltage also I have obtained, and then I have find out my line voltage, then I find out the RMS current, then real power, power factor and reactive power. Okay, and then this is the open loop. Just simply giving the voltage, I got this parameter. Okay, now what I did now, in that here is my solar input, I here input I gave a small disturbance, and again because it is now I am connected with my load and battery is also there, so that I have done a small disturbance, and again I have find out the voltage across resistive load and current through the resistive load, and then while I am doing my analysis in PI controller. Okay, so while giving the disturbance, still my converter is output voltage is changing, sorry, input voltage is changing, correspondingly there is a change in active power as well as reactive power. So to get the settle in the power as well as in output voltage, we always to have to adopt with the controller. So in the closed loop side I have moved with the PI controller. Okay, in the PI controller I have a reference voltage. So this is my solar input and this is my wind input and this is my battery, where without this my battery management technique will employ to get the constant output. So to that, this is my AC load. So while see to that, that is while applying this it takes some time. Even see, while I have changed my input voltage, what happened, it have been in a peak overshoot, and then it has reduced to oscillation, and then finally it will settle to the final value. That is my PA control. Not only in my output voltage, why you just look up on your output voltage as well as voltage across a resistive load. Resistive load means across this AC load. It's not a this is a voltage across KY boost converter means in the DC bus. This is the voltage across the DC bus. So for that, while I'm seeing to that, it have been changing, and it finally takes time to settle to the final value. So this is the voltage across resistive load, and this is the current through the resistive load, and this is active and reactive power, and finally it will settle to a final value. Yes, while I move on to that, these are my values in the PA controller. Okay, so into that I'm saying I'm not getting the better power factor and real power and all. So to increase this real power and to get the better power factor, I moved with the fuzzy logic controller. So I replaced my PA controller, just you see, I replaced my PA controller with the fuzzy logic controller, and in that fuzzy logic controller I given my reference voltage, actual voltage, and the error will be fed to that, and then you all know to that, and the derivative of that, and I have obtained the duty cycle. There you see, even I giving my disturbance, it will settle to a final value. It it is settled to a final value. So after setting to the final value, see to that my real power, reactive power, my current, voltage across resistive load, everything, my power get increased or power factor get improved. All this say to that while I'm comparing my PA controller with fuzzy logic controller, my fuzzy logic controller is giving a in terms of real power, rise time, settling time, peak time, and steady state error. I am saying that my FLC give a better results than the PA controller. So I have taken two things. One is my reference voltage I kept 300 volt, and the next case I have taken my reference voltage as a 400 volt. While comparing to that, my PA controller is not suitable for my controller, my converter. So I have chosen FLC controller. Okay, so this is the THT also we have compared. So this is the way they are saying THT, power factor, power, steady state, settling time. So all this reduced using fuzzy logic controller than using PA. It is compared by taking two reference voltage 300 volt and 400 volt. All the review results states that fuzzy model always gives the better result for the renewable energy system. This illustrates that FLC exhibits better performance than the PA controller. So even I want to do it in the hardware. So I have done in the open loop. So this is my multi-input KY boost converter, PV panel, battery, wind source, control circuit board, three-phase inverter, and resistive load. I have obtained my simulations, and this is my hardware results, and this is my simulation. I have seen whether my simulation and hardware result almost it is same only. There is a small change in that I got my ky boost converter voltage as around 80 volt I got, and here around 82 volt, and then the three phase voltage is around 70 volt, and this is without filter technique I have employed, and this is my three phase current value. Okay, so but I have done this in a hardware, but if I want to do it in a real time, the cost of the system is very high. So to avoid that, I have used the Homer software, and in particularly Homer is always for that to compare the rated capacity. I have set 2.5 kilowatts and wind rate capacity, wind main output voltage, all this, and I have obtained the uh, results. So I have just compared this data with my real-time data with my MATLAB data, and I made the conclusion that my novel multi-input KY boost converter is better than all the converter. Not only in the analyzed in the condition, it is analyzed in both open and closed loop. It have a superior characteristics like less voltage stress, good transient response, good stability, and then I compared with two controller, PA and fuzzy logic controller, and my fuzzy logic controller have a less THT value 4.96 percentage and high power factor 0.9888, and with uh, less settling time, that is quick settling time 0.47 second, and good transient response than PA controller. So this is the future work. I didn't connect it with the grid, and so I supposed to connect with the grid, and I have to employ that. And these are the papers I have published only in the area of KY converters, nearly four papers. Still 2020 also I have published. Still the papers are in pipeline, because this research I have a good idea on that, so I want to continue the research on this area. So while I'm moving to that, I have published one paper in International Journal of Power Electronics and Drives. This may you take it a reference, and you can see all these results what I have put it in the papers also. Journal of Green Engineering. And while I'm see to that, one of my paper is published in Transactions on Emerging Telecommunication Technology, and one of the paper again in this year it is published in Materials Today Proceedings. And this is the international conference published my paper. This is very first time I have published with other KY converter, but comparing that it is not giving a better results, so I gone with other converter. and now I have published the stability analysis of multi-input KY book compare, and book chapter also I have published in the Intech Open. Okay, so while I am starting my research development in power electronics, uh, uh, this is my topic I have explained. In the research development, while I am see to that, this is the area, don't forget, this is the diagram always needed while I am connecting my solar to my grid side. I can do all the research in small areas, in converters, MPPTs, controllers, filters, DC inverters, optimization algorithms, all methods I can employ. Okay, now I have a small demo on PV Sol software. That is the software simulation. I will give you, like you may download in your system, and you may check for this particular PV power how much of energy can be given to the grid, and how much of energy we can take in for the utilization. We can take it into the consideration. Okay, so I am going to explain the PV Sol. So those who are want to take the data how I am entering, you may kindly note it. Then it is used for your future purpose to in your research site. Ma'am, is it visible? Or else I will stop
Yes,
sharing.
ma'am. Yes, ma'am. It is visible.
PV Sol is visible for you? Once again, this PV Sol is visible for you?
Yes, ma'am.
Yes, ma'am.
Mm, okay, so my kind of advice is, there are so many research simulation tools are available in online. All are some of the simulation tool are open source simulation tool. So not only here I have taken one small simulation tool to explain you, but so many simulation tools are available. I think I have employed one of my research work. I have employed Homer. Why? Because now Homer can integrate all the solar, wind, and all. You all know this. While I'm doing my research work, I cannot able to implement in the real time applications. So to that we can do it in the real time applications. This simulation softwares are helping for us. So you may do your research on this kind of simulation software. Don't stick on the MATLAB alone. MATLAB, we will give on the results, but giving this MATLAB, you may take it as a system where your simulation outputs, and while you are going with this real time application, you may take it as a hardware related system, and you may compare with your MATLAB results with this hardware, that is the real time system, and then you can compare this, and you may conclude that my system is working better in the all the way. So that we can conclude. So here, while I'm looking on the PV Sol, this is uh, when you download it, it will be used for 30 days only. So even once it is completed, again you can download and you can do. There are so many simulation software tools are available. While I'm doing solar GIS, PV GIS, SAM, system advisory model, um, Homer, PV Syst, PV Sol, there are systems available, so you may search in that. And so many research paper is also available on this. So I think one of my research paper I will show for you. Okay, this is I have written using PV Sol. Integration of grid connected PV system with electric appliances, electric vehicle, and battery system using PV Sol software. So this I have used. So while you see to this, um, uh, I'll directly go to my diagram. So when you see, I have used this PV. I have used dual tracking. You all know there is a single tracking, no tracking, dual tracking. So I have taken three module of PVs. One I have chosen dual tracking, and one I have chosen single tracking, and one I have chosen no tracking. Then what I have connected one electric vehicle, one battery, okay, and one with a grid connected, and another with consumption. So while see to that, this all three are my input. Okay, my consumptions, I have chosen my electric vehicle is one of my consumption, and my other loads like residential load or any other load I can choose as my consumption. And battery all know that when PV is not available, it's a supporting storage system. I have used battery also, and grid also I have connected. That's why I have give the title investigation of grid connected PV system with electrical appliances, electrical vehicles, and battery system using PV Sol software. Only the software I have developed, I have think. So you see to that, these are my PV panel ratings and all available. I have told you I have used the three different tracking, single tracking, dual tracking, no tracking and all. And this is my PV energy during observation period. So you all know this particular PV where I have put my area. Na, I have analyzed in the PV analysis is taken at the location of Meenambakam, Chennai. You all know the latitude and longitude. So we can analyze for our own area. Not only we cannot able to think that we can able to analyze the potential in particular area. So in that particular area, how it will take the data, na 10 years of data. From that the paper will be taken into the analysis. Okay, so here you just see this is the energy forecasting. So I have uses the PV energy, how far my PV energy is used. I think you may see well here. Yeah, this particular graph, you just see this is my PV generation. Okay, this is grid, how much of energy is going to grid, and how much of energy is used for battery charging, and how many of energy is used for charging the electric vehicle. Okay, and how many is used for direct own use. So when you see to that, when you see according to the month also, the PV concept, PV production is also get different. So you see that the yellow color indicates that PV energy, and among that I am feeding maximum to my grid as well as my electric vehicle, and the remaining used for my charging the battery, and the remaining used for my feeding the grid. And once you take this, this is also the same way. Okay, this is electrical apparel consumption by different. So how my electric consumption, my grid consumption, my charger consumption, this is the way they have explained the same diagram. Here only uses of P with the PV energy sources, this is with without PV energy sources, how they have developed. You just see this diagram. It is specifically tell you what appliances, standby consumption for inverter and for battery charging, and for electric vehicle charging, all this distribution of electrical energy, these are all simulation results for you. Okay, and this is the clear picture. You please kindly note down, it's a clear picture. Actually I have this PV energy model, 3 energy module, so that my energy I am feeding to my grid. Not only to my grid, I am using for my consumption. I am not directly using for my consumption. Some of the power have been delivered to the battery, and in that battery it will be stored, and the stored energy also fed to consumption as well as electric vehicle. And from the electric vehicle it is not consuming anything to the consumption. So consumption we will receive from PV, we receive from battery system, we receive from grid. And while see to that, um, I'll see to that this is the energy flow graph. So and then the components, PV system components, the inverters, how working. Okay, so the overall consumption, I think I will explain you what are the charging power, what are the how many vehicle I have charged, all this detail. So you may search this paper, this is my paper title. You may search it, and you may get about the concept of using the PV Sol software, and you may do it for your own research work also. Okay. Okay, now I think the software, you just install the PV Sol software. It's available directly in the net.
Ma'am?
Hello, sir.
Yes, ma'am. Now you are audible, ma'am.
I think I will tell the PV Sol software to use it. Then you may use it for your research purpose. Okay, sir. Anthony Sarla, sir.
Ah, yes, ma'am. Yes, ma'am.
I think I will finish within 5 minutes, sir.
Okay,
You may
ma'am. Sure.
continue.
Okay, ma'am.
Okay. 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 Yeah. Yeah. I think it is visible for you all. Okay. So use this PV Sol software. So here you may enter your what kind of system you are choosing, grid connected or grid connected with the electrical appliances or grid connected. If you're choosing this grid connected electrical appliance standalone, all this is available. So here when I am going to my choose my country India and choosing our own location Chennai, we can type and search. Choose our own location. Okay, here you can add your consumption. Okay, add consumption in sense you they have a inbuilt load profiles also. They have a load profiles like various industries consumption. So you just see there are so many load profiles are there. So here, so even you can take it for hospital or research institute. So you are choosing research institute now, automatically it will be developed. So you have to click on OK. Then PV panel. So here you have to choose the different, actually model area one how many number of PV panel, inclined area. Then we have to choose along with the inverter arrangement, and then electric vehicle arrangement, whether you are going to add any number of vehicles, then cable parameters, so automatically this will be drawn by the software. Then any um, energy balance, or you want a kind of price of the electricity that you have to give the data for here, then you can give the simulation. This will run for the entire year, but here I didn't set. Then automatically whatever the results you want, you may get it. Yeah, you may get it. So energy flow graph you can get it. So I used only one car and one consumption, and only one PV module and one grid. So this automatically this results per area, everything uses of PV energy. Whatever we have drawn in the graph, that we will get separately, but we have to give all the capacity, everything correctly. So once you given, even it gives the performance ratio in module, irradiations level, PV energy level, temperature per module area, state of charge of electric vehicle, everything we have. So many softwares, renewable energy softwares are available, so that you can do your research development in power electronics to obtain the research by sitting, not only needed for with the hardware components and all, doing simulation, at least your results will be matched 80 percentage with that research, and it may leads to help the development in renewable side. Okay, I think. Thank you all for your cooperation.
Thank you, ma'am. The session was really interesting and informative, ma'am. Hope our participants will
Thank
gain
you, ma'am.
information from this session. I
uh,
request the Anthony Chandler sir to felicitate our chief guest with momentum. Please, sir.
Thank you, sir.
Thank you, ma'am. Now I request Mrs. Nitya, ma'am, Assistant Professor of Display Department, to deliver the vote of thanks. Ma'am, kindly
Ma'am,
Nitya, ma'am, kindly unmute, ma'am.
It's my privilege to have asked you to propose a vote of thanks on this occasion. Pursuing your patience makes you more interesting, and interesting peoples are enchanting. On behalf of FTP, I extend a very heartily thanks to our chief guest, Dr. M. Pushpavali ma'am, for enlightening us with their knowledge. Next, I would like to thank our managing director, sir, Dr. N. Mary Wilson, and our principal ma'am, Dr. L.M. Merlin Livingston, and Mr. Anthony Charles, Assistant Professor, HOD, Department of Electrical and Electronics Engineering, and also thank our EC and Triple staff members, Electrical and Electronics Engineering, JPR Institute of Technology, for providing encouragement and support to organize the event. At last, I would like to thank the entire crew of an event and made it a grand success. Thank you, ma'am.
Thank you, ma'am.
thank you, ma'am.
Once
Nice.
again, I thank Dr. M. Pushpali, ma'am, for enlightening us with their knowledge. Today's faculty development program was full of information and knowledge. I request the participant to fill the feedback form, which is posted in the chat box, to get e-certificates. Thank you, ma'am.
Thank you.
Thank you for spending your time with us, ma'am.
Thank you. Thank you all.
Thank you. Thank you.
Sir, ஒழுங்கா சொல்லுங்க.